Here is some definition of book 1 of the elements. A few definition. First is a point is that which has no part. A point is here. It is has a no part, no length, no breadth. We know that about this. A line is a breathless line. So suppose a line is not a breath. Okay, so a line is breathless line. The ends of a line are points. Ends of line are points. Okay, here is points. A straight line is a line which lies with the point on itself. Okay, straight line is a line which is eventually with the point on itself. Okay, is the dotted. A surface is that which has a length and breadth only. Surface has a length and breadth only. The edge of the surface is line. We know that. This is the suppose surface is the matchbox. Is the surface. This is the edge is line. Here edge is line. Here edge is line. Okay. Here edge is line. Okay. A plane surface is a surface which lies evenly with the straight lines on itself. Okay, a plane surface is surface which lies evenly with the straight lines in itself. This is the definition, few definition of book number 1 elements. Okay, here some of Euclid's axioms are that first, things which are equal to the same things are equal to one another. Suppose A is equal to C and B is equal to C, then A is equal to B. Suppose suppose A is equal to C and B is equal to also C, then C is the common thing. Okay, then A is equal to B. Okay. Second, if equals are added to equals, the wholes are equal. Suppose two equal things here. Suppose I want to say that suppose I take one equation. Okay, first I take one equation is that suppose I take the one is the 6 plus 7 is equal to 13. Here 5 plus 8 is equal to 13. I suppose I can add something in both sides. Sum is equal to sum add. Here is 2 plus 2 and here is also plus 2. Then 13 plus यहाँ पे होगा 2. यहाँ पे in 13 plus 2 यानी 15. Here is 15. 6 plus 2 7 8. 8 plus 7 15. 5 plus 8 13 plus 2 15. Suppose both sides add some same letter, then we can get answer the same things. Okay, this is the our post axiom 2. If equals are added to equals, okay, the wholes are equal. If equals are subtract from equals, then the remainders are equal. Suppose I can take as it is this example 6 plus 7 and here 5 plus 8 is here. So 6 plus 7 is equal to 13. Here 5 plus 8 is equal to also 13. I can subtract here minus negative 2 and suppose I subtract both sides negative 2. So then 13 negative 2, 6 plus 7 13, negative 2 is equal to 11. 5 plus 8 13, negative 2 is equal to 11. Then 13 minus 2 is 11. Okay, then subtract remainder is the same answer. Okay, so if the equals are subtract from equals, the remainders are equal. Okay, fourth, things which are coincident with one another are equal to one another. Suppose I can take this matchbox, okay, and I take also second matchbox. Is that one and other is second matchbox. Okay, they both are same size, same color, same size, breadth, length is this the also both are same. Okay, so these things both are same. The things which considered with one another are equal to one another. Both are equal. Okay, so both are equal. Fifth, the whole is greater than the part. Whole is greater than the part. Example, if A greater than B, then there is exists C such that A is equal to B plus C. Here B is a part of A and therefore A is greater than B. Suppose I want to say that something that this is the pen. Okay, this is the one pen. I can take this is the whole pen is size. Suppose I can take half. Suppose I can this box here, part here. Then this is part is half. Yeah, half some more than part. This is the small than half full. Suppose here is full part. Suppose there is the matchbox. Okay, I can explain what this is the whole part. Okay, suppose I think that this is the one part. Okay, I can make is the half. So half is this half part is small than full. Okay, so the whole is greater than the part. This whole part is greater than the small part. Okay. 6 things which are double of some things are equal to one another. Okay, suppose we are both here is equal to, suppose I can get both side add something then double, then both are equal and sub, and so things are heavily of the same things are equal to one another. Suppose I can half both sides, then also equal to one another. Okay, get it my point? These exams. Okay, first postulates. Euclid's 5 postulates are: first postulate is a straight line may be drawn from any one point to any other point. Suppose here is the point A and here is point B. So straight line is the point, one of the point A to the another point to B is drawn like here. Okay, this is the postulate 1. Now second, a terminated line means line segment can be produced infinitely on either side. Okay, suppose line segment is here A and B. Okay, it is, we can take it to infinitely this side and this side also. Okay, now postulate 3, a circle can be drawn with any center and any radius. Okay, a circle can be drawn with any center and any radius. Okay, suppose I can take here, this is the point origin O, and we have to take 3 centimeter radius, and I can draw first circle. This is the point P of the center. Suppose center C, I can assume center C, and I can draw radius of the 5 centimeter. Then draw big circle. Okay, we can draw anything. So a circle can be drawn with any center and any radius. Okay, fourth, all right angles are equal to one another. All right angles are equal to one another. Okay, it is simple because right angle is 90. All right angles are 90. So is the same. Now postulate 5. If straight line falling on two straight lines makes interior angles on the same side of it taken together less than two right angles than two straight lines if produced infinitely meet on that side on which the sum of angles is less than two right angles. Okay, this is the postulate 5. What is the thing? This, suppose I can draw here first. Okay, here is nothing, here is the first line and here is second. Sorry, I can draw here. This is the two lines. Okay, here is L and M, here is intersect third. Okay, suppose LM and this is the P. Okay, this is the interior angle 1 and 2. This is the less than of 90s. Okay, right angle, so 90s. So one of the outer side is the big, then is some intersection. So here point intersection is A here, 1 and 2, P and Q, L M line is going to this side and intersecting point A. Okay, postulate 5 can be observed from the figure given below, that this is the L line P, this is the M line, point intersecting Q, PQ line. Here is line PQ is falling on the line L and M. Here PQ is falling L and M. The angles 1 and 2 together less than two right angles. This is the less than two right angles. Okay, the lines when produced on the side of angle 1 and 2 meet a point A. Okay, get it? This is the postulate 5. Okay, we have listened. Next video we have to study this topic is that next theorem 1. Okay, here is that two distinct lines cannot have more than one point in common. Only simple things. Two lines L and M. Here is line L, here is line M. There is the one point common. Any 2 point common is possible. Any two. Suppose I can take L here, then M here. There is 1 point common here. L is here. Suppose is on the L and M 2 point hoga. There is the 1 point M here. Suppose I can take M here. Suppose L here, then 1 point. Okay, we can draw only two distinct lines cannot have more than 1 point in common. Okay, if any common points, there one and only 1 point. Okay, two distinct lines. This is the proof. Okay. Pfeffer's axiom is given by Scottish mathematician John Pfeffer in 1729. Okay, it said that for every line Q and for every point A not lying on Q, there exists a unique line P passing through A and parallel to Q. Okay, from the figure you can see that of all the lines passing through the point A. Okay, all the line, first line passing through A, second line also passing through A, and P line is passing through point A. First, second and third, three lines are on passing to point A. Only line P is parallel to line Q. Only line P is parallel to line Q. No other lines, this line and this line. Suppose this line is L and this line is M. L and M both are lines, both are not parallel to Q. Only P line is only parallel to Q. This result can also be stated in the following form, that two distinct intersecting lines cannot be parallel to the same line. Okay, only one line parallel to it. Okay, P and Q are parallel. No more line L and M are parallel to Q. This is the Pfeffer's exam. Okay, got it?